Okay, we're doing 5-4. These are sum and difference formulas. What's sum mean? Adding. What's difference mean? Excellent. Here's the formulas. There are 6 of them. There is a sum and difference of sine, sum and difference of cosine, and sum and difference of tangent. These are literally just identities. They're formulas. So if you know what angle U is, and you know what angle V is, then you plug in U and V every place you see it. So not number, but the first example, find the exact value of each expression. Do we know what it means to find the exact?
Yeah.
Don't round, period. That means we don't round. That means I'm not pulling my calculator out. We should have no decimal answers. Okay? Find the exact answer of each expression. So we have to do the cosine of pi over 6 plus pi over 4. Now if I actually added pi over 6 plus pi over 4 together, that would be something over 12. Right? Common denominator would be 12. And do we know the values of the 12s? No. So that's why we have these formulas, so we can find values at pi over 12 by using values we know. So here we have cosine, and it's a sum formula, so I'm going to use the cosine sum formula. It says cosine u plus cosine v. So there's the cosine u plus cosine v. This would be u, and this would be v. We just use the formula. So it says to do cosine u, so I'll do cosine pi over 6, multiply that by cosine v, so cosine pi over 4, minus sine u, so sine of pi over 6, and then sine v, which is sine of pi over 4. So I just plugged in u and v, wherever the formula said to plug them in. Make sure you take your headphones out, please. Cosine of pi over 6, this is the stuff you have to know. Cosine pi over 6? Radical 3 over 2. Cosine of pi over 4? Huh? Minus sine of pi over 6? Half. And sine of pi over 4 is radical 2 over 2. How do we multiply fractions? Straight across. You can't use your calculator, because then you won't get an exact answer. So if you multiply straight across, and when you multiply a square root times a square root, you multiply what's underneath them together, and you write it as a square root. Square root of 6 over 2 times 2, 4. Minus 1 times square root of 2 is square root of 2 over 4. And then, luckily, we have a common denominator, so we will subtract those over that common denominator. So I have square root of 6 minus square root of 2 over 4. Now, can I subtract the square root of 6 minus the square root of 2 and get a square root answer? Why not? They're not the same radical. They're not the same square root. And in order for these to be like terms, they have to be the same square root. I can explain why if you really want to know, but basically, if they're not the same square root, you cannot subtract them. So this is our answer. That's it. All right. Next one. Find the exact value of the tangent of the angle, and they gave us the angle is 15 degrees. So we are finding tangent of 15 degrees. One of these is going to take up a lot of space. Let me make sure which one I tell you ahead of time. Super very small. I don't remember which one it is though. Yep, it's this one. So heads up, right small on this one. I'm gonna use it like I'm gonna use the space all the way over here. Okay, so we're gonna be doing tangent of 15 degrees. But do you know that 15 is that one of the ones we know? What are the ones we know? We know 60s, we know 45s, we know 30s. Can we make 15 using something we know? What we do? Well, I couldn't understand you. Try again. What? Do what? Oh, but we're doing sum and difference formula, so I'm not going to just multiply it by 2. I could do 45 minus 30, or 60 minus 45. Now, I've done both, so I know which one works out a little bit better. So we're going to do the one that works out a little bit better. But you could do either. Let's get the same answer either way. It's just one of them's a lot messier. So we're going to do 60 degrees minus 45 degrees, which is 15 degrees. But now we can use the tangent difference formula. So we make this first number the u, and then that's the v. I'm going to squeeze that in there as good as I can, because I got it right small, I'm telling you now. So I'm going to do tangent of 60 minus tangent of 45. Divide that by 1 plus tangent 60 multiplied by tangent 45. Maybe I'll go this way. So then I need to know what the tangent of 60 degrees is. Who knows it? Tangent of 60 degrees, what is it? Radical 30 minus what's the tangent of 45? What? That was a little slower. Then we do 1 plus, and then we have to do tangent of 60 multiplied by tangent of 45. So it's just radical 3. Radical 3 times 1, radical 3. So that should be the tangent of 15 degrees. So that should be our final answer, except we like to simplify things in math. So why is this one not simplified? There's a radical in the denominator. Now, these are a radical that you brought friends. There's a binomial in the denominator. So if you try to rationalize by multiplying the top and bottom by square root 3, you distribute it to the 1 and it wouldn't cancel out. So you have to multiply by something else. Do you remember what you have to multiply by? Does anybody remember? You have to multiply by something, but it's not just square root 3. What did you say? Do you remember what 1 minus? That is totally correct. Do you remember what it's called if I do 1 minus radical 3 rather than the bottom, which currently is 1 plus radical 3? Does anybody remember that vocabulary word? Start with a C. O. And ooh, we're getting closer. It's a conjugate. A conjugate. Where should I write that? I should write it over here. The conjugates are the ones where you multiply like a plus b and a minus b. Like they're the exact same first and last terms, but one's plus and one's minus. And why we will, well, you'll see when we're multiplying by the conjugate. You'll see. But it will get rid of the radical in the denominator. So in the numerator, if I'm multiplying 2 terms times 2 terms, I have to FOIL. So we'll do first, outer, inner, last, square root of 3. What happens when I multiply a radical 3 times radical 3? Radical 3, or radical 9, which is 3. And then we do our inner, which is minus 1, and then we do our last, which is positive radical 3. And then the denominator, our first, our outer is minus radical 3, our inner is positive radical 3, and our last is minus 3. So on the denominator, when I multiply by conjugates, what happens to all the square roots? They cancel each other out. Because conjugates, you lose the middle 2 terms. They cancel out. So we get on the bottom a negative 2. And on the top, we get 2 radical 3 minus 4. And we always reduce fractions, so we say, is that reduced all the way, or can I simplify it further? I can. How? Okay. There's 2 things, actually. You're not allowed to leave a negative in the denominator. And then we can factor a 2 out and cancel it with a 2. So what I'm going to do is I'm going to factor out of the numerator a negative 2. So that's going to change this into a negative radical 3 and then a plus 2. But factor out a negative 2 because you can't leave a negative in the denominator, but those will cancel. So I get negative radical 3 plus 2, or I'll probably write it as 2 minus radical 3 is my answer. You can check yourself on some of these easily. This one is degrees, so my calculator is in degrees. I'm going to type in 2 minus radical 3, and I get that decimal. I'm also going to type in tangent 15, the original question. Ooh, I got the same decimal. I must have the right answer. Okay, so you can kind of check your answers. Right? Next one. So the next one is find the exact value of the cosine of the angle. We're doing the cosine of 11 pi divided by 12. Is that one we know? So we have to do either adding or subtracting to get 11 pi over 12. But if I separate this to be like 1 pi over 12 and 10 pi over 12, why is that not going to help me? Yeah, that's not any that I know, and pi over 12 doesn't reduce down to any of them that I know. So start thinking about what adds up to give you 11. There's got to be something that's going to help us reduce down and be pi over 6, or pi over 3, or pi over 4. What do you say?
I would say pi over 6.
Subtracting?
6 pi over 6.
Oh, do we? But when you add fractions, hold on a second. When you add fractions, do you add the denominators? So if I did 6 pi over 6 plus 5 pi over 6, this is 11 pi over 6. On the right track, not quite though. Does somebody have another one? I'm sorry. What do you think? Can't hear you. Oh, 3 and 8. Is that right? So 3 pi over 12 and 8 pi over 12. Is that what you're thinking? So if I have the cosine of 3 pi over 12 plus 8 pi over 12, does that equal 11 pi over 12? Does it? Yes. Okay. And what is 3 pi over 12 reduced? Pi over 4. Okay, that's one I know. And what's 8 pi over 12 reduced? 2 pi over 3. And I should be able to find that one too. Now that's not the only answer. There was more than one answer you could have given. Like you had 9 pi over 12 plus 2 pi over 12 works. So you just have to find one that does work and that you know the reduced form. Alright, so we're going to be doing the sum with cosine. So I'm going to use the cosine formula. So that's to do cosine of u. So cosine pi over 4 times cosine of 2 pi over 3 minus sine pi over 4 sine 2 pi over 3. That's just using a formula from above. And then what's the cosine pi over 4? And the cosine at 2 pi over 3. I don't think I heard the total correct answer right now. Negative a half. Because cosine in the second quadrant is negative. And we do minus, and then sine at pi over 4, and sine at 2 pi over 3. Is it positive or negative in the second quadrant sine? Still hear both answers. It should be positive. Sine is the y, and y goes up in the second quadrant. And then we simplify this. Let's see, we'll get negative radical 2 over 4 minus radical 6 over 4. And they have the same denominator, so negative radical 2 minus radical 6 all over 4. And that's as far as you could go. Okay, next one, find the exact value for sine 75 degrees. We gotta know how to make 75 using the numbers we know. What do you think? 30 plus 45? So we'll do sine 30 degrees plus 45 degrees, so that's the sum with sine. I'm going to use my formula above. So I do sine of 30, cosine 45, plus cosine of 30, sine 45. And then I'm going to plug in all my numbers that I know. Sine of 30 is a half. Cosine 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Sine of 45 is radical 2 over 2. And I get radical 2 plus radical 6 over 4. Okay, turn to the back. Oh, it will be available to you. It will be available to you. I'm sorry. We should have started before lunch. These three, they're just asking you to write the expression as like one sine or one cosine or one tangent. I think I'm just going to put my answers up because of time. But basic. So what here, I'm looking at sine 60, cosine 45, cosine 60, sine 45, and then I'm just like looking at the original formulas, looking at those formulas from the front page, and seeing which one has subtraction. Okay, it's one of those two. And which one starts with sine and cosine? Well, that's sine. So then I write it as sine of u minus b, which is sine of 60 minus 45, which is sine of 50. That's like correct. So you're just kind of going backwards to figure out which one that they had expanded out. Okay. So same thing with cosine. This one here, you look and you see which one is subtraction, which one has both starting with cosine. Figure out which is u and b, and you add those together. That's all. You don't have to find the answer or anything. Just go backwards using the formula. And the tangent one, same thing. The tangent that has the minus on top is the subtracting tangent, and I get a negative angle. That's pretty easy. Let's go over to the last part. I'll post the notes if I'm going too fast. I'll post them. Okay, so then the last section says find the exact value of the trigonometric function, and it says given sine u equals 3/5. I think my hair hit the board. Sine u equals 3/5, and then cosine b equals negative 5/13, and it says they are both in quadrant 2. So I'm going to start with drawing. Quadrant 2. Oop, that's not quadrant 2. Try that again. Quadrant 2 would be there. Sine is the y over the hypotenuse. So 3/5. And while I'm at it, what's x going to be? It's going to be, I didn't hear this, but it's going to be negative 4. Because it's in the second quadrant. Yep. And then the other one is second quadrant, and they give us cosine, so I know this is negative 5, and that one's 13. And that's a triple, so I know that my y is 12, and it's in the second quadrant, y goes up, so it's positive 12. Then it says to do sine u plus b. So I'm just writing the sine u plus b formula so we don't have to keep flipping the page over. So sine u cosine v plus cosine u sine v. That's the formula. So up here, sine u, up here's sine u 3/5. And then cosine u would be the cosine in the same triangle. So it's cosine u 4/5. Then plus cosine u. Nope. Is that a v or a u? Never mind. I don't think I can read my own handwriting. Let's try this again. I'm sorry. I just can't read my own handwriting. This should be a v. Yeah. You think I could draw a v since that's what my name starts with. try that again. I am going to use cosine u over here now, so I did find it. Cosine v was given negative 5/13. And then sine v I have to find, but that's 12/13. Multiply fractions to their graphs, I get negative 15/65 plus 48/65. I add them together, and I believe it's 33/65. Yeah.
How is the fourth?
Oh, it's not. Because I made a mistake, because I'm trying to go too fast. So that should actually be negative 48, changing this top number to be negative 65. Just, you know, take a little bit more time than 2 minutes to do it.
How do you know what triangle is doing with this structure?
Well, this says U, and then this one says V, so I just went off of that. And then the next example is exactly the same. I'll post that one on the answers on Canvas. Then the very last thing says the verify. Do you remember what we do if it says verify? It means box in the side. So I'm going to box in sine x, and we're going to verify sine 3 pi minus x. We're going to do that using the difference formula from the front page. I'm done. I'm going to put it up. So what I did was I used the sum or the difference formula, and I pulled out that 3 pi, and then the x as my u and my v. And then from there, the sign at 3 pi, I drew a picture and I found where 3 pi is. But ordered pair negative 1, 0. So the sign it. Yes, but this one's cosine. That one's the answer. This one the answer's not. I'm sorry. Sine of 3 pi is 0, and then cosine of 3 pi is negative 1. You can see how I'm proving that they are equal to each other. This stuff I promise. It's really easy. You just gotta use those formulas. Keep them handy. I would give you those formulas on a quiz or test.
So this answer is homework.
Well, the review is pretty quick. You're having it, yeah. And then this one will be graded.
Are we trying to review it?
We'll turn it. So just a reminder, your review is posted on Canvas already. The answers are posted on Canvas for review. And we have a quiz. But you have 2 examples before that